For some reason, my overhead's really dark lately, and I don't know why. But I guess we're just going to have to deal with that. At least we have projection. No air conditioning, but projection is good. All right, so we're on our last unit before your final. And this unit is over radicals. So today is simply, we're going to call it 11-1 only because that's what your worksheet says. None of the section numbers are going to make a lot of sense. Some of them are going to be 11, some of them are going to be 5, because I took a mixture of things from Algebra 1-2 and a mixture of things that you're going to have in Algebra 3-4. Do you hear that? It sounds like a limping air conditioning starting up. So I'm going to review some things that you had in Algebra 1-2 for the next 3 days, and then we're going to go into some stuff that you have not had before using radicals. So everything that we're going to talk about for the next week does deal with radicals, but I'm going to give you a basic foundation first. So this is simplifying radicals. So example 1, you are to simplify. We've talked about this. So if you had the square root of 52, that's really dark, isn't it? Can you guys see that? Well, that makes it worse, huh? I can't get any brighter than that. That's as good as it gets. I'll have to put in a ticket. All right, so you need to prime factor that. So use your prime factor trees. Find out what divides into there. Off the top of my head, use your divisibility rules. 5 plus 2 is 7, so 3 and 9 doesn't go in there. 4 actually does go in there, but most of you may not realize that. So most of you are going to try 2. So 2 goes in here twice. There we go. And ladies and gentlemen, we have air. Maybe. And then 2 goes in there 6 times. 2 goes in there 26, 2, and 13, and both of those are prime. So this splits into 2 times 2 times 13. So what is it really simplified? Yeah, I can pull out a pair of 2's out in front, and then I have a 13 left underneath, so I get 2 square root of 13. All right, part B, you do this one on your own. You do the square root of 72. So prime factor it. And you could break it down to its perfect squares too if you wanted to. Or just all to primes. It's your choice. Tell the person next to you what you have. Talk, talk, talk. Talk to somebody, tell them what you have. Compare, compare. What'd you get? What'd y'all get? 6 red, 2. Okay. There's a variety of ways you could have gone about to do this. Now I didn't break this down completely into its primes because 6 is not prime. I mean, you could have broken 6 down into 2 and 3 and 2 and 3, and you would have found that you have 2 2's and 2 3's, and then a 2 left over. Or you could have recognized that 36 is a perfect square. What's the square root of 36? So from here you could have just said 6, and then I can't take the square root of that, so the 2 is left underneath. Or you could have broken 36 down into 6 and 6, noticing that those are the same. So I took a pair of 6 out in front. So there's 3 different ways you could have approached that. whatever works best for you and what you like to do best. Some of you like to prime factor all the way down and stretch it out and circle your primes. That's fine. All right, so then let's remind yourself what we do if there's variables. So example 2. You are to, oh, nope, not variables yet. Let's multiply. So you are to find the square root of 2 times the square root of 24. What do you do with that? Do I have to have like radicals to multiply? Yes or no? No. Can't these just both be underneath the same radical? Isn't that the same as 2 times 24? And then can't I break the 24 back in its primes? 4 times 6, 2 and 2, and then 2 and 3. And so what I really have are 1, 2, 3, 4 2s, and then 1, 3. So I actually have 2 pairs of 2s. So 2 2s come out in front, and I'm left with 3 underneath, bless you. So my actual final answer is 4 red 3. All right, so then let's look at something with variables. Example 3. Simplify the square root of 45, a to the 4th, b to the 5th, bless you, c to the 6th. So your 45 is exactly the same as what you had before. So you're going to simplify that 45 by prime factoring it. So I'm going to break that into its primes. What multiplies to give you 45? Really? What multiplies? 5 and 9, thank you. And then 3 and 3, or you could view 9 as being a perfect square. So I've got 3, 3, 5, and then my variables again. So I can take out a pair of 3s out in front. I'm going to leave the 5 underneath. So then what do I do with the variables? How do I take the square root of the variables? What's the square root of a to the 4th? A squared. Did you just take the square root of 4, or did you do something different? Are you allowed to take the square root of the exponent? Nope. Nope, nope, nope. You have to divide each of the exponents by 2. Why 2? Because it's a square root. If it were a cube root, we'd be dividing by 3. A 4th root, we'd be dividing by 4. And if 2 doesn't go in there evenly, your remainder that's left over stays underneath. So how many times does 2 evenly go into 4? 2 times. So I have an a squared out in front, no remainders. So I'm going to go ahead and put my radical here. I know I already have a 5 left over, no a's. 5 divided by 2, 2 goes in there how many whole times? Twice. Any remaining? 1b. And then 6 divided by 2 goes in there 3 times exactly, no remaining. Now one of the things that you need to remember is if you have a variable out here raised to an odd exponent, that could make the value out here negative. And we are asking here for what's called the principal square root. So we want it to come out positive. And so you have to put absolute values around any odd root. So our final answer is 3a squared, b squared, absolute value c cubed, square root of 5b. And I do expect you to master the square root part. I'm a little lenient on my Algebra 1-2 kids, but you guys should have that down by now. All right, then we're going to simplify fractions. So example 4. Simplify. So here we've got the square root of 12 over the square root of 15. Now you have it, or I'm sorry, not the square root of 15. I want the square root of 5. All right, so whatever's underneath the radical, you can divide those or simplify them. So if it had been 15, wouldn't 12 and 15 have a 3 in common? So you could have reduced them both by a 3. But since they don't have anything in common, how do you rationalize that? What do you do to rationalize that? Yep, square root of 5, the numerator and the denominator. And so we end up with, and I'm going to go ahead and factor out the 12. So the 12 is 2 times 2 times 3, and then times that 5, all divided by, what's radical 5 times radical 5? Just 5, no radical, because it's really the square root of 25, which is 5. So radical times itself is always the number under the radical. And this 5 cannot cancel with that 5 there. Why? Yeah, one's in a radical and one's not. And so what I can do is take out this pair of 2's out in front. And what I have left is 15 underneath, because I'm going to multiply that out, divided by 5. Then you do want to look at what's outside to see if those can be simplified, and the 2 and the 5 cannot, so that's fully simplified. All right, then B, slightly different. So B, we have the square root of 11y, so we have a variable in there, over the square root of 27. Now they're both under radicals. Can the 11 and the 27 reduce? No. So you have a choice here. You could either simplify the square root of 27 first, and then rationalize by multiplying numerator and denominator by whatever is still under the radical, or you can just multiply numerator and denominator by a square root of 27. Then you're going to have to simplify when you're done. So I'm going to go ahead and simplify the square root of 27 first. Isn't this 3 3's? Right? So can I pull out a 3 and leave a 3 under the radical? So I'm starting out with 11y over 3 rad 3. So now what would I multiply by to rationalize? Rad 3 only, because that's the only thing that's left under the radical. So rad 3 over rad 3. Aren't 11 and 3 prime? There's no way I can simplify that, so I'm going to go ahead and multiply them together. 33y all over, here's this 3, times, this is the 3 out in front, what's rad 3 times rad 3? Just 3. So we end up with square root of 33y over 9. Can that be simplified? These cannot talk to each other, right? Because one's inside and one's outside, so it cannot simplify any further. I'm done. And then C. You do this one on your own. 3 over the square root of 8, however you want to do it. Bless you. When you get an answer, share it with those around you. Bless you again. All right, so share. You should have an answer. Share, share, share. There's several ways to get it. All right, so what'd you get? Rad 6 over 4. Okay, here's how I chose to do it. I chose to do it differently than B, only so you could see that other way. You could have simplified this first to 2 rad 2. And then you would have simplified by rad 2 over rad 2. Instead, I just wanted to show you what it looked like if you chose not to simplify. So I multiplied numerator and denominator by rad 8 over rad 8. So here's radical 8 stretched out, so you get 3 2's. So I brought a pair of 2's out in front as a 2, and I multiplied the 3 times 2 is 6. Rad 8 times rad 8 is 8. But then you have to look at what's outside the radical, numerator and denominator, and see if you can simplify, which you can. So the 2 goes in the 8 4 times. All right, and then the hardest one for you guys to get and remember is conjugates. Remember conjugates with radicals? Oh boy, oh joy. So example 5. So you are to simplify. We've got 3 divided by 5 minus the square root of 2. So we cannot just simply multiply numerator and denominator by 5 minus the square root of 2, because 5 minus the square root of 2 times 5 minus the square root of 2 gives us a trinomial where the radical will not go away. You have to use what's called the conjugate. What's the conjugate of this? If it's not 5 minus the radical 2, what is it? Yeah, we want to use the difference of 2 squares factor pattern, because remember, the difference of 2 squares factor pattern, the inner and outer terms cancel in foiling, and you're only left with a squared minus b squared. Well, this is a and this is b. What's a squared? What's 5 squared? 25 minus, what's radical 2 squared? It's just 2. So we'll end up with 25 minus 2, which is 23. We'll end up with no radical, which is what we're looking for. Whereas if we had a minus here, we'd have 5 times 5 is 25. But if this were a minus, I'd have 5 times negative radical 2, which was negative 5 rad 2. And I'd have this times a positive 5, which would also be negative 5 radical 2. Wouldn't we end up with negative 10 radical 2? That's why we don't use the same sign. The only sign that changes is the middle sign. The first sign does not change. All right, so we're going to multiply this, and we're going to use parentheses, by 5 plus the square root of 2 times 5 plus the square root of 2. And so I'm going to distribute the 3. So I get 3 times 5 is 15. When you multiply, you can only multiply what's outside of a radical to what's outside, and what's inside to what's inside. So I can only multiply 3 times 1, which gives me a positive 3. There's no radical here, so I just tack on rad 2 over. Then use your a squared minus b squared factor pattern, or you can FOIL if you want to, but we're going to do 5 squared, which is 25, minus radical 2 squared, which you said was 2. If you want to FOIL, go right ahead, but it just takes longer. And so we end up with 15 plus 3 radical 2 all over 23. Then you have to look at what I like to call my Superman triangle of numbers. Superman would have an S in here, wouldn't he? That's why it's a Superman triangle of numbers. And so look at the 15, the 3, and the 23. Do they all have a common divisor? No. So we can't go any further. If they did, then you would have to divide all 3 of those by the same number, but they all 3 have to have a common divisor. If this were 25, let's just say for chuckle's sake, you cannot cancel the 15 with the 25 because the 3 doesn't go in there. So all 3 have to be cancelable for you to do any canceling because of that addition outside of parentheses. So this is your final answer. What if this had been a plus? What would this have been over here? A minus. So you'll practice that on today's homework. Any other questions or concerns? Okay, so hopefully that's all review. We'll see.